All right, hello. Let's get some music on. All right. So last time we finished up the physical, the validation layers and the message callback, so we can get some pretty good debugging going. And this time we are looking at the physical devices and family queues. Likely only just the physical devices for now. Specifically selecting a physical device, meaning a GPU. So before we begin, cheers. Let me just rearrange some stuff. I don't need to see my own face. That's good enough. All right. Hopefully that's big enough. Yep. Well, I'll say yep, but yep. Okay. So, I'll just see. Okay, cool. Okay, selecting physical device. After initializing the Vulkan library through the VK instance, we need to look for us and select a graphics card to use from the system to support the features that we need. In fact, we can select any number of graphics cards and use them simultaneously. Ooh, magic. I didn't know you could do that. I thought the game had to be using only one graphics card at a time. I don't know why I thought that. Maybe because there's a select, usually. Okay. So, but in this tutorial we will stick with the first graphics card that suits our needs. We'll add a function called pick physical device. Yes, we shall. Let's jump up the top and create a function prototype. Let's do it here. I don't know what the prototype is, but let's just stick with void for now. And it also takes in void, but experience tells me we're going to probably want to put our graphics card selection onto our abstract. So let's pass in the abstract. And then let's define it further down, but not down there, I think. Maybe somewhere. Check validation layer support. Let's put it here. And then we want to call that function in the init Vulkan function. All right. Oh yes, here we go. After we've set up our debug messenger, then we want to do this function, passing in our pointer to app. Excellent. Okay, so moving on. The graphics card that we'll end up selecting will be stored in the VK physical device handle. So it's added to the class member here. Okay, so as predicted, we're going to want to store it here. So VK physical device, physical device, VK physical device, and we're just going to call it physical device. It's not a pointer or anything fancy schmancy. Okay. This object will be implicitly destroyed when the VK instance is destroyed, so we don't need to do any cleanup. Okay, awesome. Set it to null handle for now. VK null handle, that's the first time I've seen VK null handle. How is that different to this null pointer? Maybe null pointer is actually like a void pointer or something. Well, it hasn't caused us any issues so far, so I am not worried. I am worried about how moving from Windows, Mac to Linux. Oh wait, what's my password again? Technical difficulties, sorry. Yeah, I'm worried about how moving from Mac to Linux every day is not improving. My skills are not improving. Okay. Listing the device. Okay, where we handle the object will be blah blah blah. Listing the graphics cards is very simple, similar to listing extensions, and starts with querying for the number. Alright, so let's do same old same. Let's just skip down the bottom and find the function we created. Okay, so probably gonna want to create a U32 with the name of device count, and it sets to 0 initially, and then we do VK enumerate. Ooh, wrong capitals. VK, why are you not auto-completing? Oh, because it's not a capital V. Physical device. Alright, and we're going to pass in our app instance as well as the device count. And a null pointer, which will just do null. So with that, we will get our updated device count. And then, if there are 0 devices, we don't want to support that. Okay, so if device count equals 0, then we go, oh no, man. Printf. And what should we say in terms of an error? Fail to find a TPU with Vulkan support. Fail, and then we do exit. And I'm going to say, have I done 3 yet? Nope. I'll do 3. This could be a perfect opportunity to replace these exit numbers with an actual error of some sort shortly. Otherwise, we can now allocate an array to hold all of the VK physical device handles. Cool. Let's do that with capital VK physical device types. Devices. Oh. It's gonna be what is it gonna be, a pointer to devices? Oh, of that particular count. Oh, it's not pointed to a pointer, is it? No, just a regular one. Okay, so device count. Excellent. This will hold all of our devices that we receive when we pass it back to here as the, I'm guessing, final argument. Devices.data. I wonder if that's going to be the right type. Let's just give it a quick compile and find out. Warning. VK enumerate physical device. Did you mean VK enumerate physical devices? I certainly did. It's not a single device, is it? I'm glad that it's so clear to tell me that. Alright. Excuse me. Okay, so that seems to work. We are getting our devices. Now, what do we do then? Now we need to evaluate each of them and check if they are suitable for the operations we want to perform. Because not all graphics cards are created equal. For that, we'll introduce a new function called isDeviceSuitable. Sweet. It's going to return a boolean. I'm assuming isDeviceSuitable. And we're going to receive our VK physical device. So we're going to call this for every device. Okay. It's not receiving a pointer, it's just receiving a copy of the actual device. Let's return true for now to say, yeah, they're all suitable. They're all so suitable. Create again our function prototype. Alright, and we're going to do here for int I equal to 0. If I is less than the device count, and increment I and loop through the loop. And we're probably going to say if is device suitable, passing in our device at position I, then I should also close that. Then what I want to do, physical device equals to device. Oh, I didn't see that we created a physical device. Oh, it's our app physical device. Okay, that makes sense. P app physical device equals this little chap here. Excuse me. If we found a physical device that is suitable, then we just break out of the loop. Then if we don't, we need to check and say if physical device equals null. Why VK null handle? But I'm assuming that's gonna just expand to null. That's, yeah. Here and then, oops, exit with the number 4. It's the same sort of position, so fail to find suitable GPU. Okay. Cool. This next section will introduce the first requirements that we'll check for if in the device suitable function, and we'll start using more Vulkan features in the later chapters. We will also extend the function to include more checks. Okay, so instead of just saying true to the first thing we come across, let's actually look at what they can do. To evaluate the suitability of a device, we can start by querying for some details. Basic device properties like the name, type, and supported Vulkan version can be queried using VK get physical device properties. Right. Let's just have a quick gander at that particular function. It's going to be false if we don't find any of these things, I'm assuming. So let's go here. All right, what does this function say? VK get physical device properties. Returns properties of a physical device. Lovely. What is the properties type? Take me there. API version, driver version, vendor ID, device type, device name, pipeline cache UUID. Interesting. I bet we're going to use that later. And that's the size UUID. Limits, device limits, don't know what that is. Sparse properties. Ooh, yeah, there's something called... Nah, so I want to say sparse rendering, but I don't know what it is. Oh. Very sparse related properties. Okay, I don't know, I still don't know what that is. Limit is a VK device. Limit structure specifying device specific limits. Okay, that's more like really heavy down to the details GPU stuff, which I am no expert in, or even a novice in. Alright, so we want to create some sort of object with our storing the device properties. Ooh, hello. So device properties, and then we will call get physical device properties, passing in the device and a pointer to the properties. Okay. Excuse me. The support for optional features like text compression, 64-bit floats, and multi-viewport rendering, useful for VR, can be queried using get physical device features. Okay, we also want to do that, obviously. We're not doing VR. Oh man, wrong keys. We're not doing VR, but hey-ho. Okay, cool, so we've got that. There are more details that can be queried for the device, and we'll discuss later concerning device memory and queue families. Hey, I knew about, oh, that was pipelines. But yeah, see the next section. As an example, let's say we consider our application only suitable for dedicated graphics cards that support geometry shaders. Then the is device suitable function would look like this. That gets the properties and features, and then it says device properties must be of device type discrete type, and must support geometry shaders. Now my laptop is a Lenovo ThinkPad. I'm pretty sure it does not have a discrete graphics card. I think it's one of those onboard ones, and it's an AMD broken voice, something. Cool, Radeon. That's what it is. 5. Radeon 5. Oh, it's getting dark. Alright. Let's actually follow suit and move these things further up here. Okay. Instead of just checking if the device is suitable or not, oh, and going with the first one, you could also give your device a score and pick the highest one. I like the sound of that. That way you could favor a dedicated graphics card by giving it a higher score, but fall back to an integrated GPU like mine, if that's the only one available, which it is. You could implement something like this as follows. What on earth is a multi-map? Okay. Let's create a list of candidates, loop through them, create a rate device suitability function, which returns a score based on the device, and then we insert all the candidates along with their scores. I mean, all the devices along with their scores into candidates, making pairs. So it looks like some sort of just a list of arrays, a list of maps or pairs or tuples or whatever the hell you might want to call it in C++. We're not going to do that. I'm just going to be a bit more simple. And let's just bust up one here. I'm going to say, oh, I don't want to say int. Yeah. I'll say int. Oh, it's going to be unsigned. It's never going to be negative, is it? So U32. It's going to be pretty big. Rate device suitability. That's a VK physical device. And then we're going to be stealing all of this, putting it into this function here. So get all of the device properties and the device features, and then let's create a U32 score, initially set to 0, and then if device properties dot device type equals VK. I'm just going to copy that. Isn't that way I'm typing that out without making a mistake? If it's a dedicated GPU, then set the score to be plus equals 1000. Hell's fire. All right. I'll also make a note and say, same as that, discrete GPUs have a significant performance advantage. Evidently, I mean, supposedly. Then a maximum possible size of textures affecting graphics quality. Okay, so this device properties limits maximum image dimension size means you can just do more image stuff. So application, nope. Maximum possible size of textures, quality. I'll just use the same notes. Device props dot limit dot max image dimension 2D. Then finally, applications don't function without geometry shaders. Yeah. Oh, not don't, can't. Either. Can't function without geometry. Okay, so if there's no device features dot g score set to 0, and then return the score. Okay, so here we're gonna just whack out this and say U32 score device. So in our suitable devices, I think we would like, I'm going to do a quick to do because I need to run out and put the chickens to bed. Not a euphemism, they actually have chickens that I need to put to bed. Okay, create little struct to hold device and its score. So it'll be something like VK physical device, device, and U32. Ooh, score. Something like that. But for now, I'll be right back. Alright, we are back. Chickens are asleep. Well, no, they're not, they're in bed. Squawking away, the little tiny babies. Alright, cheers. So, thinking about making some little struct. That will be our device along with its score. And then from there, when we loop through all the available devices, so we need to loop through all the available devices and attach a score, and then also loop through again and get the top score. I don't know about that. It doesn't sound particularly amazing, does it? What could be the alternatives to doing that? Perhaps having perhaps having a device object and a score, so like a tracker device, tracker score, set to null initially, loop through. So the first one to be those two, the score and the actual device. And then if we come across a score larger, we assign that. Single loop, happy days. A little bit of extra stack allocation, but better than nothing. But no need to do a struct then. So that's cool. Okay, so is device suitable? Then we could do, not is device suitable. In that case, we probably don't want to do this is device suitable thing. Is device suitable? Oops. Is device suitable? There it is. Ideally, we're not going to break if it's suitable because there are like a bunch of them could be suitable depending on what kind of computer you have. Normally, you wouldn't have heaps of GPUs, would you? I don't know, crazy people these days. I think a better way to do this would be scrap that and just go have a tracker of VK physical device DVICE. So that's our single device, and as well as the U32 device score initially set to 0. Okay, and we'll set that. I think it's like initially set to null. So we'll say for each device count, let's say if device, now we're checking this a lot. Let's first get the score. So let's get the score for the devices at position I. Then we can set our device score. Or actually, first we'll say if score is more than device score, then we're going to update the device score as well as the device. So the device score would then equal score, and we would set the device to equal devices position I. Then so then after we've done that full loop of all the devices, there's not going to be heaps, so it's not the end of the world if it just continues, there's no break. We will check if not device, physical device, but actually just device is set. If that doesn't equal null, will that equal null there? I wonder. Let's just put a print in. Only if device equals null. We'll go, yeah, printf. Device starts as null. Or mul. Mul reminded me of Kroll just then. And Robbie Coltrane died recently, so that's pretty sad. Totally off topic, but there you go. Okay, so if you have no device, do that. And if we do, then we set that to our device. And we don't really care about the scores, that gets cleaned up for us. Right, let us run that build. Error. Oh, what have I done there? Oh, it's got to equal that. You can't just assign it, idiot. Alright, rate device suitability. Passing in our device. What's the error? At top level, 227, warning implicit declaration of function rate. Oh, yes. It's down here, so let's... yeah, we're going to probably put it into a header file and break them out into their own source files, so I'll happily create another one. Sorry, I'll happily create a function prototype up here, so it can then be referenced down there. Okay, let's try it again. Because one error, VK physical device properties has no member named limit. Does it not? Oh, because it's limits. Find dot limit. Next time, try reading it. I want to see a print. Device starts with null. Starts as null. And looks like we probably found a device. So, is there a function we're not using? I think there was. The suitable one, wasn't it? This one. Is device suitable? I'm not using that function. So let's delete that. We actually just check if it's suitable within this function. Okay. Groovy. Yep. So here we're using it. Let's then say printf device selected. I could give the device name, couldn't I? Let's take a look at what a VK physical device looks like. Oh, well, there's the device name, but what about a VK physical device? Oh, no, sorry, didn't mean to do that. VK physical device. Oh, this is the properties. There you go. What's on the physical device? Specification, blah, 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 blah. Oh, I thought that was a struct because of like opaque handle to a physical device object. Oh. Right. Well, I tell you what, just for S's and giggles, let's call that again. VK physical device properties and that's the struct. I want to get the physical device properties, so same thing here. I'm just going to be cheeky and do this. Give me my physical device properties. All right, and then I'm going to print out device selected, and it's going to be a string, I think, and it's going to be our physical device properties, and it's going to be the device name. Device name. It's not going to be a arrow. It's probably just going to be a dot. Yes. Build game. Null. Radv Renoir, which I think is the Radeon. Ah, device name, huh? Device type? Let's see what that comes up as. Just out of more curiosity. Oh. Device type is a VK physical device type. What on earth is that? Let's take a look at what's on that particular object. It's an enum. Oh, so it's just a number depending on if it's a GPU, discrete, integrated, or virtual. Ooh, let's see what number it is then. So that's it. type is, and type is 1. 1 translates to integrated GPU, because I'm a cheapskate with a cheap laptop. Okay, excellent. Okay, I kind of want to know the features. Actually, I want to know a better name, but I guess, nah. Hey ho. Okay, well at least that works. That's cool. I don't need to call this junk again. I will call device selected. Actually, I'll say GPU selected. Hey, whoa, whoa, whoa. Okay. Right. So from that point, we've got our score. La 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 la. You don't need to implement all of the tutorial. Yeah, okay, it's fine, but the idea. Of course, you can also just display the names of the choices and allow the user to select. Yes, that's what I thought you could do, but because we're just starting out, Vulkan support is the only thing we need, and therefore we'll settle for any GPU. Oh well, we've got a little extra checking, and it's kind of nice to have those scores. This video may already be pretty long, so let's quit it there and let's get back to Q families in the next one. So let's say get status, and we're only going to do main, get add main, and get commit, select adds GPU selection, get push origin main. Excellent. That'll do. So until next time, see ya.